All right. Just waiting. Oop. All right. There we go. Now we're on. Just going to wait a few moments, a few seconds for people to drop on in. Welcome those viewers who are already here. Good to see ya. That's right, I see you. All right, well, let's get this show on the road. Greetings, techers from around the world. Welcome to TechArt Talk Live. My name is Chris, and I'll be your host for today's session. And today's session is going to be the third week of a 7-week series of where I am going to blitzkrieg Python into your old noggins. And this is the third week, and this is actually the second week of super good content. And if you're with me so far, then congratulations. That means you're in it for the long run. And if you're just dropping in, well, welcome. We try to catch up, keep up with the best that you can. Now, just as a reminder, we are working with Python 3.7 using Houdini as a IDE, which means we're using it as the internet or the interactive development environment. However, I'm not necessarily just focusing on Houdini Python. Really, I'm focusing on just Python, and I'm throwing Houdini to throw a little contextual elements along with it. All right, we've got a lot to cover today, so let's go ahead and get things rocking and rolling. Okay, I'm going to go ahead and shift my view here. All right. Let me make sure that you can see my crazy mug here. Okay. All right, now there I am. Hey, there I am. All right, cool. So let's keep things moving. Now, last week we gave a basic introduction into Python basics and a little bit of Python logic. So this week we're going to be working with functions and intricate data within the Python language. So you're probably going, what are functions? Well, it kind of like breaks down to this. Functions, modules, and packages. Functions are callable code that is used to perform basic tasks. They're kind of like bread and butter. They're little tools that you can make. Modules are collections of tools or collections of functions, usually stored in a separate file, and they're used for accessing information or accessing tool sets or accessing suites only when you need them. Packages are a collection of modules, and those are usually entire folders that contain lots of different modules, and each of the modules contains different functions. So it all is kind of a hierarchical into it. But we're going to focus just on functions and modules today. Okay, so this is kind of like what a function looks like in Python. It starts off with the def statement, DEF. Then it's followed by a function name, and then you give it the arguments. Now the arguments have to be in parentheses here, and then it's followed by a colon. The colon has to be there or else Python doesn't know what to deal with it. So it's going to need something that tells it, hey, bub, we're at the end of the line here. We need to know where your statement block is. And this is where you put the statement block, right underneath that. But here's the important part. It's got to be indented 4 spaces in. Not, you could hook up your tab in order to equate to 4 spaces, but it's got to be 4 spaces. That is according to the Python Tech, or the Python PEP 8 standard. So there you go. And then the last thing a function has to do is return something, and it's got to use the word return. It's looking for that, and it's going to return some kind of value. Now the arguments going into the function are this kind of like the interface of the function. It tells you how to configure and how to use the function. It explains how the functions can be used. And a function always has to, regardless one way or the other, it has to return some kind of value. If it doesn't, if you don't have a return statement, then it's going to return a 1 or a 0 if it's successful or it's not. And so here, I wanted to create just a very, very simple, basic little function that's just too simple, and we'll call it square. So I'm going to go ahead and go into Houdini here. I'm going to create my a little shelf. I didn't save my shelf from last time. Actually, I had to reinstall my version of Houdini So I'm going to go ahead and create a new shelf set, and I'm going to call this my edit shelf. I'm going to call it TATL, or Tick Art Talk Live. And then I'm going to add a new tool. And this new tool I'm going to add is just called Square. Nice and simple. Square, and we'll call this Square. All right, let's go to the script. Take a look at it. All right, once again, the first thing you need to do in order to define what a function is, just use the def statement. So it's DEF. And then the name of the function is, we're going to call this Square. And then we're going to call some kind of argument. And we don't know what kind of argument. Well, in this case, I'm lying. We have to do what kind of argument. We're just going to put in one floating point value. So I'm going to drop in a value of y in here. And that's followed by a colon, so that we know to the end of the line. And so I'm going to tab forward so we are indent one place. And then I'm going to go right to, I'm not even going to create a block of code. I'm just going to go right to the return statement. I'm going to say return y times y. Okay. That's my function. I know it's not terribly fantastic. It's not terribly exciting. But how would we go about calling this? We would say, okay, let's go say print square of, I don't know, 4. Let's see what happens there. If I click apply, and then we go ahead and we execute, and then it prints out 16. Not terribly exciting, not crazy sophisticated, but what do you expect out of a 2-line function? Not the Earth, Sun, and the Moon. That will take at least 3 lines. All right, let's put in something a little bit more robust here. How about 18.631? Okay, I'm going to apply. And click this, and the square of that is 347.1. Hey, Mac, everyone knew that, right? Of course they did. All right, so much for that trivial introduction. Let's go on to some bigger stuff. And so I'm going to create a more juicier function that does something a little bit more robust. Let's create a clamp function. So I'm going to right-click on this and go to New Tool. And I'm going to go to Options. I'm going to call this Clamp. Clamp, okay, very good. And then I'm going to grab the information here. All right. So I'm going to put this. Okay, what we have here is a quick function. Here's my def statement, so that defines it as a function. Clamp is the name of my function, and then I'm going to have 3 arguments inside of this. 3 parameters: value, min, and then max. And so here's the first line of our code here, where it says result equals val if val is less than max, else, or else than max. So what this statement is saying, this is a fancy way of writing an if statement and an assignment, a variable assignment statement, all in one sentence. So we say, okay, set result equal to val if val is less than max. However, set result equal to max if the opposite is true. And likewise, if check the result is greater than min. If it is greater than min, then set result equals to the result, or set the result equal to min if the result is actually less than min. And then we finally want to return the result. All right, I'm going to go ahead and add some information here. And I'm going to put in a little bit of code to execute our function. We're going to say A equals 15, B equals 20, C equals 40. So we're going to start off with our value, which is 15. So it should get clamped somewhere between 20 and 40. And let's see what happens. Click apply, clamp, and then you say it's got clamped at 20, because 15 is less than 20, so therefore it got clamped right at 20. Now if we wanted to put something in between here, let's say about Oh, 34.76. Let's see what happens here. Clamp. And it still is probably because I am using an integer. Let's go ahead and use something else other than an integer. So apply. Clicking 20. Okay. So there we go. Now we've got this going here. So we've got this thing about the scope, the scope rules here. And how do we know what variable names to use? Now, when the variable stays local within the context, or where are they going to be found global? And you need to use something called a global variable in order for that to be understood. So I'm going to create one more additional function here, a new tool, and I'm going to call this global. All right, I'm going to put my script open here. Okay, so I'm going to first go ahead and create two functions here, and then I'll explain what I mean by that. Okay, notice out here the first thing I defined was foo. Foo equals 1, and so this is going to be a global variable. And so we create a new function, a function called a. And the first line of that, we're going to assign the value of 25 to foo. And then we're going to print, hey, the local variable of foo belongs to this function. And so we're going to give the value of a, print the value of a. Then what we're going to do is we're going to add the value of 1 to it. This is a fancy way of saying, instead of foo plus equals 1, this equals, effectively, is foo plus 1. But I kind of like things doing it the old way, which is kind of like the fast, cleaner way. And so this is going to take this, and it's going to increment it by 1, and then it's going to print out its value. Now, notice that these don't have return statements in them, and that's because we don't want to really return any data, but they are going to return a 0 or 1 if it was successfully completed in its execution. Now, let's look at function B. Notice that we declared a variable called global foo. Global foo means, okay, don't use a local variable, use the global variable, which is sitting up there. We're just going to print out its value, and then we're going to multiply it by 10, and then we're going to print out its new value. Okay, so notice that this is not working on a local variable of foo, it's working on the global variable, which is actually very important. And so, let's go ahead and move things along here. I'm going to write a little quick script to actually get this thing on the road. All right, we're going to print the global value of foo right off the statement. Then we're going to assign the global variable value of foo to 7, and then we're going to print its value again. So it's going to start off, we're going to print out 1, and then it's going to go to 7. Then it's going to go to A. Then it's going to show you what A thinks that foo should be. Then it's going to go in what B thinks foo should be. Notice that A should not be changing the value of foo, but B should, because it's accessing foo as a global variable. We're going to call A again, and once again, A is going to be totally unaware of the global value of foo. Then we're going to call B again, and B is going to continue right where we left off the last time we called B, and we're going to make modifications with it again. So if I click Apply, and click Global, all right, here it is. Global value of foo starts off at 1, which leave that here, and then here we have 7. Okay, so we have the local variable foo in the function of A. It goes in at 25, and then it leaves at 26 because we added the value of 1. Then we go into function B. We said, okay, going into the value, we're using the global variable, so it's now a value of 7. We're multiplying it by 10, so therefore it is a value of 70, which is fine. And then it returns. Now we're going to go back to A. Now notice that the A function, the global function in A, is back to 25, so it's doing exactly the same thing as it did before. So therefore it's going to increment it by 1 and then leave. Now we're going to go into B once more. And when we go into B, we're going to see where it takes up where we left off, and that is the value of foo, which is a global variable. And you say, okay, foo is 70. Then we're going to multiply it by 10, and then say, okay, then foo then equals 700. And so that leaves where the statement is. Now, if we wanted to put one more statement in here to finally verify, is foo actually changed for good? I'll put this statement in here one more time. Click apply. And I'm going to put some space in here. And then you see that by the end here, the global variable of foo has been changed radically. And it's not through function A, it's done through function B. So that's a big statement. Okay, now we got to start talking about default arguments. Now, what are default arguments? Default arguments are argument values that kind of like is where your script or your function goes to if you decide that you forget or you don't want to put the argument in there. Sometimes you don't feel like it. Sometimes you're lazy. You don't want to type out all those things. So let's create a new tool here called defaults. Okay, we're going to create a very simple function here. And we're going to call it something to compute the box volume. Okay, notice here, def box volume, where we say length equals 1. So here in the parameter, we're assigning the local variable name, but we're assigning the local variable name within the argument list itself. So here we say length equals 1, and so we're initializing it with a default value. So that means if the calling person doesn't identify the argument of length, then go ahead and use the value of 1. Likewise, do the same with width and the same as height. And then just go ahead and return length times width times height. Now let's put this in action a few times. Okay, let's get this going. Okay, we're just going to print out the box value. So we're just going to call this once and see what it says. And we see it has a value of 1. Why is that? Because by default, length, width, and height all equal 1, and we're using the default values. So what if we want to make this a little bit more sophisticated? And we put the value of 3 in here. What does that mean? Okay, what it's going to do is it's going to put the arguments in order here. And it's going to assume, okay, since we are giving any kind of designation there, then go ahead and set the length equal to 3. Because we're not putting any information in here for the width spot, go ahead and use the value of 1, and go ahead and use the value of 1 for height as well. I'm going to go ahead and apply, click, and you say it has 1 and then 3. So that means it's 3 times 1 times 1. All right, if we were to do this one last time, and let's go ahead, if we wanted to set the specific values on things. So we might want to say height equals, I don't know, 5, and then say width equals 3. All right, so what this function is going to do, we've designated a value for height and designated a value for width, calling the Python function, but we didn't have one for length, so it's going to use the default value for that. So we're going to hit apply here. And then when we execute our box volume, let me create some space here. We're going to get the value of 15. So really, what the values that we're putting into it are 1, 3, and 5. 1 times 3 times 5 is 15. And so those are the default arguments. Now, let's start focusing about modules. Now, modules are collections of functions. There are a whole bunch of functions stacked up into one place. So I'm going to go ahead and fast forward through this. Okay, and you access a module by at the top of your script or top of your environment, you use the word import. You use the word import and then the module name. And then you have to use that module name to tell Python where you're getting that function from. So it's module name, the name of the function, and then its arguments. Now, what this establishes here is this word here as the module name is what's called the namespace. And the namespace is what keeps functions of different modules, but it's named the same, all playing nicely with each other. Now, suppose that we had module A had a function called foo, and then module B had a function called foo. Well, we'd have to say a.foo for the first function and b.foo for the second function. All right, let's take a look to see what this is going to look like. And the best thing of doing it is to use like this simple math library. I'm going to use this right here, and I'm going to say import math. Python doesn't really have too many math smarts associated with it. You have to tell it, okay, Python, go ahead, bring in your math, and that's what we're going to do, import math. So now we have the math library available to us. So if I want to print, and I say math.sqrt, which stands for square root, and we'll put a value of 900 on here. Okay, now we're going to print using math square root of 900. All right, and it says, okay, the value of 30. Now, if we didn't use the namespace that explains where we got that function from, look what happens. We're going to get an error. It said square root is not defined, and that's because Python doesn't know where to find square root. But square root is defined within that module that has been loaded in, so we have to use that namespace for that module. And likewise, if we use some kind of funky values, like negative 900, okay, we also, oh, I forgot to put the namespace in there. So it's math dot square root. Okay, notice we still get an error, but this time we get an error that has math domain error. Because why? It's because we put a negative number inside of square root, and since we're not working with imaginary numbers, that number doesn't really exist, so that's why Python complained. But really, that's all that there is to it. And when you ever include something into a module, then what you have to do is create a namespace. All right. So let's expand that just a little bit further, and let's do something that's a little bit more visually interesting. And I'm going to create a new tool, and I'm going to call it Roberto's, or Roberto's. Roberto's. Like it's got stinky feet. Roberto's. Okay, so what we're going to do is we're going to use some math, and we're going to play with some Roberto action here. Okay, so the first thing I'm going to do is I'm going to import my math. All right, now we have math. That means we have access to the full library. And then I'm going to create a function of which you've already seen before. But we're going to create a function that has a little bit of character parameteristics to it. So we're going to say draw Roberto. And then inside of it, we're going to give an X position and a Z position. So with the first line here, we're going to set the who node according to the top node. So we want the top node right here sitting up there. Then we want to create a geometry node. And we're going to call it geometry node Roberto. And then we're going to create from the Roberto, we're going to create inside of it the test geometry rubber toy. And we're going to call it Roberto and set to the value of geo here. Then, since I want this to be moved and otherwise animated inside world space, then I'm going to grab my container object or my geometry object. I'm not going to grab the actual SOP inside of it. I'm going to grab the geometry object, and then I'm going to set its parameter. But this time, instead of going tx, ty, tz times 3, I'm going to call a parm tuple. And so we're going to call it t. And notice that we didn't say x, y, z, because all we want is t. So it's going to be understood that we're going to send it a 3-tuple value. And then we're going to have an x value, a y value, and a z value. And that's exactly what we do here, is because we have set. And then inside set, we're going to send it a tuple. And it's a tuple because it is bound by these parentheses. And what we're going to be sending inside of it is the x position, a value for 0, and z position. You might ask, why are we going to be putting 0 in for the value of y? And it's because we're just going to create kind of like a geometric pattern with Roberto, and we really don't need it to have any kind of height. All we want it to have is x value and depth for the z. So let's go ahead and create a little function to use. Let's create a little program to use our function draw Roberto. This is just a simple little function. I'm going to create a local variable called radius, and I'll set it to 2.5. And Roberto's is the number of Roberto's I want. And so I'm going to set up a very simple loop. I'll say for I in range Roberto's. So this is range Roberto's is going to return a sequence starting from 0 going all the way up to 9. And then I'm going to set the local angle. Okay, I'm going to go and say, like, okay, we want the local angle. What we're going to do is we're going to take 360 degrees, divide it by the number of Roberto's, and then we're going to multiply that result by a value I, and that's going to give us our angle. Notice that we're saying math.radians. So we are converting math.radians is a little conversion function that converts degrees, this is 360 degrees, and it converts it into radians. Because cosine and sine are trigonometric functions, and they like to behave with radians rather than degrees. And so we're going to say the x position equals the radius times math.cosine of the angle. And we're going to say the z position is the radius times the math times the sine of the angle. So it's really almost the exact same thing. And then we're going to call our draw Roberto function with our new x position and our new z position. So we're going to call this draw Roberto function basically 10 times. I'm going to click accept, apply here. And then we're going to hit Roberto's. And there we go. We have a whole stream of Roberto's. And there are our 9 geometry objects right in here. And so this is very, it's a nice simple little demonstration of how we can quickly. Now, if we wanted to run this simulation again with some more, so let's just say we have 20 Roberto's. Well, I say, okay, if I want to put 20 Roberto's in here, then I might want to increase my radius to maybe, let's 4, so that the Roberto's have some room so they won't be colliding with each other. I'll click apply and run my function, and there they are. Well, they're still colliding with each other, just slightly, but we've got 20 Roberto's now, all formed within a circle. Isn't that nice? It looks like they're going off to the opera together. Ha ha ha. Okay, now, what we're doing, this is one technique for importing a module. There are actual multiple techniques that we can include. Okay. So this is the one we did before. Import the module name, and we use the module name and the function. Okay, we said we need the module name as a namespace. Now we could instead say from the particular module, import only the specific function. So like, don't include the entire function. I just want you to include just one of those functions. And that's all it's going to pull in. And we're going to say, okay, cool. It's going to pull that. Now, if we really want to be lazy, we would just say from that particular module, import star. And the star means everything. Bring in everything. Now, something interesting happens when you bring in everything. It removes the need for a it removes the need for the use of a namespace, so we don't need the module name any longer. And that's a very interesting distinction to see what when you're dealing with is not dealing with this. So let's try that again. Okay, let me go back to my Roberto function. Okay, it's right here. And now we're going to say from math import star. Okay. Then what we could do here is we say, okay, we don't want to deal with all of this math namespace. So here, it's the first time I call the math namespace with the radian, so I'm just going to get rid of that math namespace. I'm going to get rid of that here. I'm going to get rid of it here in this cosine statement. I'm going to get rid of it in the sine statement. And let's change things up again. Let's make it, let's go for broke. 30 Robertos. And let's make sure that this is got a radius of maybe 7? I don't know. We'll see what happens. We'll see if that works. Apply. Let me get rid of my Robertos. Hit refresh, and there they are. 30 Robertos all in a nice little circle. And notice here that in this function, I didn't use the math namespace, and that's because I imported a star. And when you do that, you get rid of the need for the namespace. Kind of cool. Okay. Now let's move on to the ingrained or the natural data functions that are found inside of Python. And they're all called sequences. Now, we were introduced to sequences before because when we wanted a for loop, then we needed a sequence. But sequences are often called arrays in other languages, and they store some kind of related items. And so in Python, there are 3 array types, or 3 sequence types, or 3 data structures, and they're called strings, lists, and tuples. Now, there's one extra one called hashes, or they're called associative arrays, and otherwise known as key value pairs. They're called dictionaries. So we have 4 basic ingrained types of data inside of Python. They're called strings, lists, tuples, and dictionaries. Okay, so let's go ahead and start playing around with this stuff firsthand. All right, so if I wanted to work with just some strings, I would say foo equals, and then we put double quotes here, tech art. Okay, that array is, or that string is now a sequence. And we're going to go bar equals animation. That is another sequence called a string. All right. Now let's have an example of a list. A list is bound with square brackets. So we're going to have here, we're going to call this a list, and we've got all those numbers on here. And it doesn't have to, notice that all I have here are integers. They don't have to be integers, and the cool thing about Python lists is that the values don't have to all be homogeneous. That means they don't have to be all the same data type. You can get a variable kind of data type. So let's create another list. And here, you'll see that another list equals 23, which is an integer, 3D, which is a string, Maya is a string, and then 67.4 is a float. So we can mix things up and have things up. So actually, it goes even deeper than that because we can put not only strings inside of here, floats and integers, but we could put other lists in as well. Ooh, multi-dimensional lists. Now we're getting fancy. Now the third type that we're going to deal with are tuples. Now tuples are like lists, but they're designated with curved brackets or the parentheses. And they behave very, very similar to lists, except for one unique distinction. And like lists, we can move them or change their values around. Okay, they're very fun. And so tuples and lists look like they produce very, very similar results. So before we go on to the difference here, let's talk real quickly about dictionaries. Dictionaries are they're key hash values because these are not, dictionaries don't need they have special ways of accessing that information. So I'm going to create a dictionary here. Okay, the first value, we're going to call it 1, which is an integer. And then we're going to go Jerry. The second is going to be a string called Mark. 3 is going to call Bob 1. 4 is designated as Bob 2. And 5 is Alan. And like another dictionary, the type of data doesn't have to necessarily follow this formula. Here I have is another dictionary. Now, its key I have is a string, and here's my value. It's a value of 76, but here in this case, my key is the value 63, and my value is a float. And here my key is is a integer, and my value is a string. So we can mix these up now there's an important distinction to make, and that is that certain variables are mutable, or they can change, and some are not changeable. And it's important to understand the distinction about them is that sequences that can change are called mutable, and lists and dictionaries are immutable. That means once they are created, you can change them. That means you can move them around. Now, sequences that don't change are called immutable, and tuples and strings are examples of immutable sequences. That means you can't change them. And before we go on to start mucking around with this, let me go on to something a little bit of how we index all of these sequences here. I'm going to go pull up my notes here. Okay, there we have our list of tuples, dictionaries. Okay, now here we have is a list of values. It could be this could be a list, this could be a tuple. It doesn't really matter. But notice that at the top of the list, we want the first value. We have to start counting at 0. And then the second value is 1. The third is 2, and so forth, all the way down to the very final one. Notice that since we're starting at 0, then we're not dealing with the normal numbers. What we're dealing with is counting it over. We're going to count at 0, and then we're going to go all the way to n-1 at the very end. Now, in Python, it is possible to use negative index values. And those negative index values kind of start at the end. If we were to go to -1, that would be the very last one. Because remember, if we were to go to the 0th one, that would be the first. -1 would be the last. -2 index would be the second last. -3 would be the third last, and then so forth all the way down the line. Now notice that this does go from -1 to -10 in a kind of a little bit more of a logical sense. Okay, let's focus then on creating lists and strings and tuples. Okay, so we've already identified that we've created a string, and it has to have some kind of quotation marks around it. A list is bound by the square brackets, and a tuple is bound by the round brackets. You might want to say, okay, if lists and tuples are basically doing the same thing, but a list can change and a tuple can't change, well, what good is it? Well, tuples are really good for storing what I like to call homogeneous data. That means that if we're going to be working with a whole data set, they're very similar to each other, then stick them inside of a tuple, especially if you know they're not going to change. If you want to change things, then you want them to be heterogeneous, then go ahead and use a list. A list is really good for creating variables that are of different types, all jammed up and put into each other. Now, if we wanted to create an empty string, I would say a string equal, and then I would use double quotes, and that is going to create an empty string. That means there's nothing inside of it. And likewise, if we wanted to create an empty list, which is mutable over time, I would say a list equals open square brackets, close square brackets. And when the tuple is just the same, I'd say a tuple equals open parentheses and then close parentheses. Now, tuples are a little bit magical too, is that you can create them multiple ways. And we showed how to do them with the parentheses. Now, if we're going to be lazy and we wanted to create them without the parentheses, we can only do this for tuples. We would say a tuple equals 1, 2, 3, 4, and that is totally fine. So we could go print a tuple, and it says, okay, fine, that's all thing. And notice that it does put the parenthesis around it to designate to the user that it is a tuple. Now, here's something that's interesting. A tuple is also a single value here. If we just put this in as a single value, 84, that's fine too. It is a single variable, but in Python, a single variable is a tuple of length 1. That means that it's called a singleton, and that is the only way of doing things. Now, let me go ahead and show you a way of working with lists. Okay, there are, we're not going to go into, we don't really have the time to go into every one of these, but here are the methods associated with every one when you're dealing with the lists. You can append to a list. You can extend it, meaning like if you've got two lists, you can slap one list on top of another. You can insert an item or another list inside of an already existing list. You can remove an element, and you have to tell which element to remove. You can sort them if you put in some kind of comparison function. You can count them. That tells you how many elements you have inside of your list. Your index says, okay, we're going to put, okay, list, tell us what your index is for this element here. Like if we didn't know where we had Bob1, I say, okay, what is our index of Bob1? And it will go and tell us that. Pop removes the object of the index location. It removes it from the list. And reverse does exactly that. It reverses the method around. Okay, so I'm going to go ahead and create another function here. Now suppose we wanted to unpack them. Now I myself don't really use this too often inside of Python as a tech artist, but I thought I would throw this by you all the same. And I'm going to call this unpack. So this is a way of parsing through a tuple or a list or even a string without having to actually change anything. And so let me go ahead and throw this here. There we go. Okay, I'm going to find my string as quotes ABC. I'm going to find my list as a list with square brackets, 1, 2, 3. And I'm going to create my tuple as parentheses, and inside I'm going to put a string X, a string Y, and a string Z. And so in this first statement, I'm going to say first, comma, second, third, equals a string. And so what Python does is it takes the value of string and then it tries to fill it within each of these values. And then we're going to print out its values. And the same thing with lists and the same thing with tuples. Notice that I say first, second, third equals my string, my list, and my tuple, and then I print out those values of first, second, and third uniquely. So when I go ahead and execute this, we get they've been broken up into little things. And this is what is called unpacking. Do tech artists unpack a lot? No, they don't usually unpack a lot, but they can. Okay, so what is the fourth type of data function that we're using this? And we have these things called dictionaries. Now, dictionaries are created. If you want to create an empty dictionary, I'm going to call a dict, equals, you use curly brackets in there to designate a dictionary. Okay, so we have an empty dictionary, and then we wanted to put some information in here. So a dict, a dict equals, and starts with a curly bracket, and then we have its key. A key is the way that you access this information. And so for this case, I'm going to just use the value of 1. And then the value is what's on the other side of that colon. So we're going to go just with the letter of 1. That's not what that says. That's OP. We want just 1. All right. And that's our first entry. Our second entry, we have to do the same thing. We have to put its key. And in this case, I'm just using the value 2, colon, and then some kind of value. And in this case, I'm going to just use the string 2. Okay, that's why these are called dictionaries, are populated with what's called as key value pairs. So you have a key and you have a value, and they come one into one. They come with each other. Now, we can't use standard indexing when we're trying to access this. So if I wanted to access the second value, I say a dict, and give me the second value. Well, even if I put the first value here, it comes across with 1, but that's not what I wanted. Why did it confuse that? And that is because it's using 1 as my index. So if we wanted to create the value of 2 as the index, that would work that way too. Now, what if we wanted to change this around to be something a little bit more like this? Say 1. And put this value here as, just something different. We'll just call it 11. And this key, we're going to change it to the string of 2. And put its value as something else, 22. Okay, it doesn't mind. But when we access a dictionary and we put the value of 1, it's going to go, I don't understand what that means. But if we wanted to put the word in a string called 1, then it gives me that. And we'd have to do the same if we wanted to use the second one, 2. All right, and so that's how you go ahead and you set those values. And then if you wanted to append a new value to the dictionary, let's just say a dict and then we wanted to set like a value of maybe 3. And then we set it to equal something in here. Let's call it 333.333. Lots of 3s. All right. So now we want to tell us, okay, give us the value of a dict 3. And then it pops in that value. Okay, let's go ahead and create this a little bit more. Because there are, like lists, there are a whole bunch of things that you can do with dictionaries. And I'm going to create a new tool here. I'll create dictionary. I'm just going to call this dict. Part of me just likes saying dict. Hey, this is a dict statement. Okay. All right, so we have our empty dictionary. We're going to create it as 0. Then first thing we're going to do is print out the value of the empty dictionary. And then we're going to say, okay, grades, and then we're going to put in 4 key value pairs. We're going to have the keys as Emma, Gypsy, Tom Servo, and Crow. And the values are 87, 84, 96, and 90. And so we're going to print out all those grades. And then we're going to print out just what Gypsy's grades are. So we're going to access the value of Gypsy. And then we're going to change Gypsy's value to 92. So therefore, Gypsy's got a new value of 92. But what if Bubba entered the class and we wanted to edit Bubba's grades here? Then we'd say grades for Bubba. That would create a new entry within our hash table. And then we could show what the grades look like after the modification. And then if we wanted to delete Crow from our list, like suppose they got COVID, had to go do sequestered for a couple weeks, what we could do is just say delete Crow or del grades Crow, and that would remove it from there. So let's go ahead and execute this. Oops, syntax errors. Don't tell me. Where is my syntax error? Grades, the thing, invalid syntax. Okay, line 8. Okay, well, let's look at line 8 here. All right, so I'm missing a parenthesis here. Let's see if this works. Oh, more thing. Okay, we got line 11, so this is done in a couple places. So we have line 9, grades Bubba. Okay, so this is missing here. Okay, is there any other places where I have any mistakes? I don't know. Let's click here. Okay, so there it is. So the empty value of the dictionary is printed there. There's the value of our class grades right after the bat. We wanted to see what the Gypsy's current grades are. We updated Gypsy's grade, and so that's fine. Then we have our modification, and then we put in the value of Bubba, and then we removed Crow from the list altogether. And that shows you that the series does work. And so here are all the list of all the items that you can do with dictionaries. They are quite useful things. You can append to them, meaning that you can add new value to the end of the list. You can extend them by getting 2 dictionaries and extending them together. And likewise, you can insert information inside of a dictionary at a specific index. You can remove an element, like what we did in the example. We can sort them. We can count them. Oh, wait, this is our list method. It's not a dictionary method. Ah, there they are. Clear, copy, get, has key, items, keys. Now, the big thing to do this is where it's got keys and it has values. Okay, the keys actually returns all of the keys used in the items are its values. Okay, pop item removes it from the top, and update changes things up. This one iterates through the keys, and one iterates through its values and items. Okay, the thing about dictionaries is that the ordering is kind of willy-nilly. You never really know what you're going to deal with when you're dealing with dictionaries. So therefore, don't get used to assuming that the data is in order inside dictionaries. If you need to order your data, use a list or a tuple. Those hold the ordering on your data very well. Not so much dictionaries. Dictionary is something if you want kind of like an abstract key and some kind of willy-nilly values associated with that. Okay, that's really what I wanted to show you today. But I wanted to show you one more item. We have a little extra time, so I'm going to take advantage of it. I'm going to show you something that's really, really cool that I really, really like, as a tech artist. Today's lecture has been kind of dry, not really too much Houdini going on here, but I'm going to change that right here in a bit. I'm going to deal with something called recursion. Now, recursion is a special type of function that calls itself either directly or indirectly. And if it's going to be calling itself, you're saying, hey, wait a second, bub. If we're going to be calling itself, does that mean it's going to keep calling itself until time finishes? And the answer is possibly. It depends. So what we have to do is we have to give it a simple case to provide which acts as a break. You remember when we were doing while loops last week? We had to put in a break. Well, we have to put in a break when we're calling a recursive call. And we have to give it some way of kicking out of the recursive loop before we actually get into calling itself forever. So I'm going to create just a simple little recursive loop here, and we're going to call this factorial. Nice and simple. I love recursion. Here it is. Chris is going to show off some stuff that he loves to play with. Factorial. Okay. Factorial. Okay. I missed my I and my A around. Factorial. Okay, there's my function. Here it is. Very, very simple. But immediately what I'm going to do is I'm going to put in my break. I say, okay, if the number that I have coming in is less than 1, then I'm going to kick out and say return a value of 1, meaning I am okay. If it is greater than 1, then what I'm going to do is I'm going to return the current number I have against, I'm going to call my function again, factorial, but I'm going to call the number minus 1. So you guys all might remember what a factorial is. And a factorial is a function that multiplies itself, and then it multiplies by the number beneath it, and then the number beneath it. So it would be like 5 times 4 times 3 times 2 times 1. Well, that's what this function does. And so what I've got here is I'm going to type in a little call to this. Okay, I thought I had this. All right, there we go. This is one big old line. So what I'm going to do is ask input and say enter an integer. All right, we're going to type something in, and then we're going to convert it to an integer using the int function. Then we're going to give it the factorial, and then the factorial is going to compute the factorial of that number. And then we're going to go and print that value again. So click apply. So if I click factorial, it's going to say enter an integer. If we put in the value of 5, then it's going to go 5 times 4 times 3 times 2.1, and that's 120. All right, now that's pretty cool. It called it itself. So that is a real tiny function. Let's run this again with something a little bit more complicated. Well, let's call it like 22. Whoa, that's a huge number, and that was done really, really fast. It didn't used to take that fast years ago. It used to take a lot longer than that to do 22. But as you can see, that pumped out a gargantuan number really, really quick. And that's what the factorial function is. Okay. Let me see. Hopefully I can get this working. And this is a call for all you riggers out there, because when you're rigging, you might want to know what all the bones are. But if you haven't had a chance to find out what the bones are, then you're going to be kind of stuck. And so I'm going to add a new shelf here. I'm going to add the character shelves here. And then I'm going to just add in a simple female. So we have a female character. Now she's sitting down here. And if we go into the female character, if we look, she's a little bit complicated. And we look in there, we've got bones, we've got controllers, we've got a whole bunch of gobbledygook. And we said, this is just too much information. Just give me a way, just give me the bones. So what you could do is write a little script to kind of recurse through this character and identify all our bones. And I'm going to call this, I'm going to create a new function here called new tool, and I'm called bone finder. Okay, inside of this, we're going to have a very simple little script here. And if all goes well, this will work. Now here's our script. We're going to call bone finder, and we're going to tell it, okay, what level are we at? Because not only are we going to keep track of the bones, but we're going to keep track of what level it is because we're going to recurse rather than layer, and then sometimes we have children and children children. We want to keep track of the apparent hierarchy. And so what we're going to do here is we're going to check the name of every single thing. If it has the word bone in here, then what we're going to do is we're going to print out its value and say, okay, hey, we have a bone. So we're going to check every node type. We're going to recurse through this tree, and every one of these node types, we're going to see if it's a bone. If it's a bone, then we're going to print it out. Now, if it's not, then what we're going to do is we're going to, for every one of these nodes, we're going to examine all of its children. And then for every one of these children, we're going to call bone finder on it. And so technically what this is going to do is we're going to recurse through the entire tree in order to figure out where all our bones are. You know, nice and simple. If I click apply here, and then I click bone finder, oh, we've got another syntax error. Oh, wrong version of Python, folks. This was written in the 2.7 days. So I'm going to click this over here, and click that on here, click apply. And now let's see what happens. We got another syntax error. Line 3. We're still not good with this print statement. Okay. Print statement. It's taking bones. Print. Is this here? If we print that. Okay. That is done. Did we forget to apply here? Okay. And then, so what I'm going to do here is, okay, I know what's wrong because we're doing Python 3.7 here, and it doesn't like this print statement. So let's go ahead and, is this going to work? Let me give this a try. All right, I'll click apply. Is this going to work? Nope. Okay. So what we're going to have to do then is just print out the level and print out its the name of that level. So I'm going to go ahead and modify this up a little bit. I'll put a format in here, curly brackets, and then colon curly brackets, and in here we're going to put a dot format, and then inside of there we've got the little name, and I think we're going to need one more parenthesis. Is that right? No, I think that should be about right. So we've got 1, 2, 3. And 1, 2, 3, that should be right. So now let's click apply. Syntax error, point 3. Oh, great. It is not cooperating at all. It really doesn't want this. It's not taking in my change value. Okay, great. Thank you, Houdini. So I'm going to go and copy this and then cancel this, and I'll create a new tool here called Bone Finder 2. I'm going to call it BF2. BF2, okay. Script, and now let's see if this works. All right, there we see. Now what we've done is we've gone through and we've traversed this entire rig and found out where all of its bones are. Notice that it indented this according to the hierarchy where all these are. And so what we see here is a list of only the bones that are characterly inside of this character. Okay, that's what I wanted to go through with you folks today. Let me go ahead and get things. Let me get my exit going out of here. All right, very good. All right, so check if you like what you're seeing. Check us out for Houdini Secrets Live this afternoon, and we're going to show VAT 3, and we're going to show the third part of our VAT series, and we're going to show all about what are we going to show today? We're going to show about fire and fluids here, and then check us out for Houdini Talk next week, and I forgot to update this slide, but we are going to be showing next Friday, and then what we're going to be showing are an introduction to VDBs. We're going to show up how to represent your geometry in volumes. I've never really learned the ins and outs of this, and so it'll be a learning experience for everybody. Okay, and so if you like what you see, check us out, subscribe to this channel, and go ahead and subscribe me to on YouTube, and check us out on Facebook. My name is Chris Rhoda at YouTube, on Facebook, and then check us out on LinkedIn as well. And as well, check us out at TechArt.edu on Facebook and LinkedIn as well. But if you really want to help us, please go on over to the website, which is TechArtEDU.com, and then go ahead, and there's a little banner there that says click here now. What that will do is bring you up to a little pop-up where you can go ahead and jump in there and get access to the most recent information that we have here. And get on my mailing list. Get the information, you get to hear about all the goodies and all the stuff going on here, and get informed about what is cool. Well, thank you very much for joining us today. Thank you very much for our Tech Art Talk Live. And if you're going to be joining us for Houdini, I'll see you again at 3 o'clock for the Houdini Secrets Live. And otherwise, I'll see you all again next week for another episode of Tech Art EDU.